This last mini lecture today is going to be about buoyancy. The buoyant force is the net upward force on an object in a fluid. So imagine that we have a cylinder of water here. This is our little cylinder of water. Inside a beaker of water. And the water around the cylinder is holding up that little cylinder of water. So we've got our little kind of imaginary boundary around the cylinder of water. The water surrounding it is holding up that imaginary boundary for that cylinder of water. It provides, that surrounding water provides a net upward force equal to the weight of this little cylinder of water we can draw a boundary around. So when an object is immersed in a fluid, it displaces, meaning it pushes out of the way, the fluid that would otherwise fill that region of space. And this fluid that the object that is submerged is pushing out of the way, we call the displaced fluid. And this is Archimedes' principle. A fluid exerts an upward buoyant force on an object immersed in or floating on a liquid. The magnitude of this buoyant force equals the weight of the fluid displaced by the object. So every object that is in water, floating in water, submersed in water, it experiences this buoyant force. When you're in the bathtub, you experience this buoyant force. And this buoyant force is equal to the weight of the fluid that the body is displacing, or that the body is pushing out of the way. That's equal to the mass of the fluid displaced times gravity. That's also equal to, so we can rearrange the equation for density. Density is equal to mass over volume. We can rearrange that equation and solve it for mass. And the mass is also equal to the density of the fluid times the volume of the fluid. So we can say that the buoyant force is also equal to the density of the fluid times the volume of the fluid that's been displaced times gravity. There are three possible scenarios for objects experiencing buoyancy. The first is that you have a sinking object. An object will sink if it weighs more than the fluid it displaces. So in that case, the density of the object is much, much greater than the density of the fluid. So if your density of your object is greater than the density of the fluid, you will sink. If you drop something that's made of iron into water, it's going to sink because the density of iron is much, much greater than the density of water. An object will float if that object's density is much, much less than water. An object will, if you hold that object underneath the surface of a liquid and you let it go, the object will rise to the surface if it weighs less than the fluid it displaces, because it is experiencing a net upward buoyant force that's greater than the weight of the fluid it is displacing. And in that case, the average density of that object is less than the density of the fluid it's displacing. And finally, an object will remain motionless inside a liquid if it weighs exactly the same as the fluid it displaces. That also means that this object must have the same density as the fluid that it is displacing. And we call that neutral buoyancy, when the density of the object is the same as the density of the fluid it is displacing. And then it will just sort of hang out within the liquid without moving up or moving down. It's also the case that partially submerged objects in static equilibrium have a unique relationship. So if you are floating, let's say, a piece of wood on water, part of that piece of wood is going to be submerged under the water, and part of it is going to be above the water. And in that case, this is the case for an object that floats. And in that case, you can calculate the fraction of that object that is submerged just by taking the ratio of the density of that object that is floating to the density of the fluid that it is floating within. So the ratio of the volume of the fluid that is displaced to the volume of the object is equal to the density of the object that's floating divided by the density of the fluid that it is displacing.